When I was a child, I used to play video games where the world would render as I moved through it. I'd watch fascinated as new landscapes appeared at the edge of my screen. Little did I know that decades later, I'd be wondering if our entire universe works in surprisingly similar ways. In 2011, the Nobel Prize in Physics went to scientists who discovered something that shocked the foundations of cosmology. Our universe isn't just expanding, it's accelerating. Galaxies aren't just drifting away from each other, they're speeding away faster and faster as time passes. This completely contradicted what we expected. Gravity should be slowing cosmic expansion down, not speeding it up. It was as if you threw a ball upward and instead of falling back to Earth, it shot off into the sky with increasing speed. To explain this, physicists proposed something called dark energy, an invisible force permeating empty space, pushing everything apart. It makes up about 68% of our universe, yet we have absolutely no idea what it is. The standard explanation involves Einstein's cosmological constant, a value he originally introduced to keep the universe static, then rejected when Hubble showed the universe was expanding. Einstein called it his greatest blunder. Ironically, it's now central to explaining why that expansion is accelerating. But here's where things get truly strange. When physicists try to calculate how much energy should exist in empty space using quantum field theory, they get a value that's off by a factor of 10 to the power of 120. That's a 1 followed by 120 zeros. It's often called the worst theoretical prediction in physics history. What if this massive discrepancy isn't a mistake but a clue? Consider for a moment the controversial idea that our reality is actually a simulation, a vast cosmic program running on unimaginably advanced technology. I know how that sounds, but bear with me. In a video game, distant areas aren't fully rendered until needed. The system allocates resources dynamically. If our universe were simulated, could dark energy be essentially the same thing? A mechanism for expanding digital space-time as the simulation grows more complex? When we try to understand quantum vacuum energy and get bizarre results, perhaps we're glimpsing the underlying code, like finding a seam in the fabric of reality where the programming shows through. Think about quantum mechanics, where particles exist as probabilities until measured. This behavior frustrates physicists but makes perfect sense in a simulation context. Why calculate precise positions for billions of particles when you only need to determine values when something interacts with them? The simulation hypothesis might even explain the extreme fine-tuning we observe in our universe. The fundamental constants of nature, the strength of gravity, the charge of an electron, the strong nuclear force, all seem precisely calibrated to allow for stars, planets, and ultimately life to exist. Change any of these values slightly and our universe would be unable to support complexity. Is this incredible fine-tuning just cosmic luck, or were these parameters set deliberately? There are potential ways to test this hypothesis. If space-time is digitized at the smallest scales, high-energy cosmic rays might reveal subtle directional preferences, like detecting the pixels on a screen if you look closely enough. Some physicists are already looking for these patterns. About 7 billion years ago, our universe switched from decelerating to accelerating, a transition that occurred at a curiously opportune moment for conscious life to eventually evolve. In a simulated reality, this timing might not be coincidental but programmed. If we are in a simulation, who created it and why? Perhaps an advanced civilization studying cosmic evolution, or creating ancestors to learn from their history. Maybe our reality is nested within countless layers of simulations, each created by beings in their own simulated worlds. This isn't just philosophy. The nature of dark energy directly shapes our universe's destiny. If it's constant, our universe will expand forever, growing colder and emptier until even atoms dissolve into the void, the heat death scenario. But if dark energy is part of a simulation's architecture, the expansion could change at any moment, perhaps slowing or even reversing if the programmers decide to alter parameters. The idea that our reality is simulated doesn't diminish its meaning. Whether the stars are made of plasma or pixels, our experiences, connections, and discoveries remain profound. Consciousness doesn't become less valuable if it exists within a programmed reality. The wonder of existence persists regardless of its substrate. Each time I look at the night sky now, I see it differently. The accelerating galaxies, the cosmic web of structure, the mysterious dark energy pushing everything apart, all of it might be the most elaborate code ever written. And we, in our curiosity, are reverse engineering the universe itself, perhaps coming closer than we realize to understanding the true nature of our reality. Whether we're biological beings on a planet circling an average star, or consciousness embedded in the most sophisticated simulation imaginable, one thing remains the same. We keep asking questions. And maybe that, the endless questioning, is the whole point after all.